Welcome to the video for 9.3, more about parabolas and their applications. And note, we're only covering objectives 1 and 2. So some basics about parabolas. Well, first off, parabolas come from the equations, the quadratic equations. So ax squared plus bx plus c equals 0. Remember, this is quadratic because it has that x squared. It's the highest power we see. So that would be the equation. It's the quadratic equation, and when we graph it, we get something like a parabola. And in this class, the only two parabolas we're looking at are the ones that open upwards or downwards. Okay, upwards or downwards. So that's the main thing one of the main differences is we could have opening up or opening down. And how do we know if it opens up or down? Well, we base it off of the a value, the value next to the x squared. If that a value is positive, so if it's greater than 0, then it opens up. If a is less than 0, then it opens down. What's something else that we know about parabolas? Well, there's something called the line of symmetry. It runs right in the middle of the parabola, so it may not necessarily be on the axis. Let me go ahead and draw a quick sketch of the side. I'll erase this. You might have a parabola up and off to the side here, and the axis of symmetry, or the line of symmetry, would be running right through the middle. Let me go ahead and graph it in red. And what do we care, or why do we care about that? Well, basically, if I have a point on this side that's, let's say, 2 units away from this line in the middle, I know that there will be a point exactly to the exact opposite direction. 1, 2. It's not perfectly graphed, but yes. Alright, so it would be exactly 2 away. So that is the line of symmetry. Now, another interesting fact about parabolas. We will always have a y-intercept. Let me rewrite that, always. Have a y-intercept, but we may not always have an x-intercept. Why is that? Well, just take a look at the one I drew here on the side. Are there any x-intercepts? No. It's above the x-axis right here. But because parabolas will continually get wider and wider as you graph them, at some point this will cross the x-axis somewhere over there. Now, one other important thing about parabolas is something called the vertex, and it's at the main point that passes through this line of symmetry, and this point is called the vertex. And this one right here would be a vertex. So what is the importance of a vertex? Well, if you look at the one on the side here, this vertex would be the smallest possible number on my graph. So this would be the minimum number. And then the one up here, this is the largest possible number on my graph. It's the top number, the big dog, right? So this would be the maximum number. Okay, so that's just a basic sort of overview of parabolas. Once again, if you want to get any more in-depth detail on specifics of the parabola, please remember to read the textbook for each section. Alright, so let's take a look at something called the Vertex Formula. Alright, so this is the formula for finding, well, yes, the vertex. So if you have your function f of x equals ax squared plus bx plus c, the vertex, which we would indicate with a capital V, is going to be, now the vertex, remember, is a point. So it's going to have an x value and it's going to have a y value. Alright, so what do we know about this vertex? Well, the x value is going to be negative b over 2a. It's the formula. So when we're working this out, we call it v sub x. It will be negative b over 2a. And we get the b and a values from, that's right, from the equation. And then how do we find the v sub x value? Or sorry, the v sub y value? Because remember, it's a point, so we need an x and a y. Well, when we're solving this, the way to find the x value is the same. It's always negative b over 2a. The way to find the y value changes. Why? Well, because it depends on our equation we're given. So all you do is you take the value you found for x, and then you plug that into your function to solve for y. So the way I'm going to note that here would be f of negative b over 2a. So you just input that value you found from your x value, you input it into your function, this one right here that you're given for each problem, to find your y. Alright, and that's the vertex. So let's take a look at something called the 5 steps for graphing a parabola. Now these are important. Once again, some of you may have different ways of graphing parabolas, but the 5 things I see here are the things that I need to look for and need to find on your work when I'm grading. It does not necessarily have to be in this order, but these are the items I'm looking for. Alright, so the first thing I'm looking for, I want you to list your ABC values. A, B, C values. What are those? Well, once again, when you have the equation ax squared plus bx plus c equals your function f of x, or 0, your a value is the one by the x squared, b is by the x, and c is the one by itself. And on this step, remember, what does the a value tell us? It tells us if my parabola is opening up or down. So you need to indicate on this step. You could write out opening up or opening down, but you could just give me the symbol. This would be for opening up, happy face. This would be opening for down. So either one, depending on the case. Now, the next step would be to find the vertex. And once again, that is negative b over 2a, and then f of negative b over 2a. And the third step, find the intercepts. Alright, fourth step would be any extra points. So this is something that's important here. You need to have 5 points shown for the parabola. I can count pretty well up to 5, so I will make sure, or you need to make sure, that you include 5 points on your graph. How do we find these? Well, you can use the XY table, or you could use the line of symmetry. Either one. Option 1, option 2. And the last step is your graph. However, most of the time, it's easier to put all of these values in as you go along and just complete your graph at the end. Alright, so those are the steps. Let's take a look at using them. So example 1, graph the following parabola using the 5-step method. Alright, so what's the first step? Step 1. List our ABCs. Well, the a value is near the x squared. So what is that? We don't see anything, but we can assume it's the positive 1. So a is a positive 1, and is that positive or negative? Well, it's positive, so my parabola is opening upwards. Why is that important to write down? I'll tell you about that in a sec. Okay, then my b value is going to be negative 6, and my c value is going to be 5. And just a hint, your c value is always going to be your y-intercept. Why is that? Because when I input 0 for x, all of these values will cancel out, and I'm always left with the last number. Jumping ahead of myself a bit. Okay. So the next step, what's step 2? It's finding our vertex. So I'm going to go ahead and get ready, just label this out. So let's go ahead and find v sub x first. That's negative b over 2a. So that'll be negative b over 2 times a. And what was my b value? My b value was negative 6. Once again, be careful. We have double and negative, so make sure to use those parentheses. And my a value was 1. So that's going to be 6 over 2, which is 3. Go ahead and plug that 3 in right there. Now we need to find v sub y. How do I do that? Well, I just use my equation I'm given right here. This tells me how to find y, because remember, f of x is equal to y. So y is going to equal x squared minus 6x plus 5. And what is the x value? Well, we found it. Right here, it's 3. So let's go ahead and replace that with 3 to find my y. Because once again, remember, f of x is the same thing as y. So squared minus 6 plus 5. 3. 9 minus 6 times 3 is going to be 18 plus 5. 9 minus 18 is negative 9. Plus 5, negative 9 plus 5 is negative 4. And we're done. So there's my vertex. Alright, let's go ahead and plot this real quick. And I'll tell you why we're going to do that. Well, my vertex is 3, -4. So let's see. I'm going to graph this in red. Why not? Nah, let's do blue. Okay. +3, -4, down here. This is my vertex. I'm going to go ahead and label it V and then do 3, -4, which please make sure to do that, to label your vertex with a V, so I know that you know that it's the vertex. Now, in the next step, step 3, I'm going to be finding my intercepts, right? My x-intercept and my y-intercept. But first off, just looking at my graph, do you think we're going to have x-intercepts or y-intercepts? Well, remember, we always have a y-intercept, but we may not necessarily have x-intercepts. How do I know if I'm going to have an x-intercept? There's two possibilities, remember? It could open up, and then I would have x-intercepts because it would cross the axis here. But if my parabola opened down, I wouldn't have any x-intercepts. And remember, when you're solving for x-intercepts, you're going to be using a quadratic formula. And you don't want to be fiddling around with this thing for eternity, so you want to make sure you're not trying to find something unnecessarily. What option are we looking at? Well, remember, it opens up, which means we are going to have 2 x-intercepts. So I know I'll be able to find them and not waste time. Because one time I was in my actual exam when I was in Math 103, and I spent a large amount of time trying to find x-intercepts, and finally graphed my points and realized there were no x-intercepts. So I wasted some time, and I don't want you to make the same mistake. Alright, so let's go ahead and find my intercepts. So first off, let me write down my equation. So f of x, x squared minus 6x plus 5. So let's find x-intercepts. How do we find x? We set y equal to 0. So 0 equals x squared minus 6x plus 5. Does this factor? Let's see, x minus 1 and x, oops, wrong color, and x minus 5. Okay, yes, it does factor, so let's go ahead and do the zero factor property. So set each factor equal to 0. Solving for each factor. X equals 1. And add 5, x equals 5. So we have 2 intercepts, and once again, we need to write them in the proper format. I do grade for this. Okay, they're points, so you need to indicate that they are points. And let's go ahead and graph those points. So 1, 0, 5, 0. 1, 0, 5, 0. And another way to check that we've found the right intercepts is our vertex should be specifically or smack dab in between these guys. Once again, this line of symmetry that I'm drawing in red, it's not actually a part of your graph, so you don't need to actually draw it in. I'm just showing you, I'm going to call it LS, line of symmetry. As you can see, these 2 points are exactly 2 units away from each other. And that's how all the points on this parabola will be. Okay, so we found the x-intercepts. What are we missing? The y-intercept. Let's go ahead and find that. So the y-intercept. How do we find y-intercepts? We set x to 0. So f of 0 is going to equal 0 squared plus or minus 6 times 0 plus 5. These all go to 0, and we're just left with f of 0 equals 5, which we mentioned earlier. So f of 0 equals 5. That's my y-intercept. 0, 5. Right there. Okay, so we've completed step 3. What is step 4? Remember, step 4 is extra points. And I can use the table of values to find extra points, or I could use the line of symmetry. Let's see, is it possible to use the line of symmetry? Well, these 2 points already have their matching side. But this point doesn't have a matching side, so I can use the line of symmetry to find it. 5 is 1 to 3 away from the center, which means a point exists 3 the other direction. So 1, 2, 3. That point must exist, and that would be at 6, 5. And there we go, we have 5 points. 1, 2, 3, 4, 5. Let's go ahead and draw in our parabola. This is not perfect, but please note it should have a curved sort of structure to it, and then the arrowheads indicating it's going off to infinity. Alrighty, and that is it for graphing the parabola. Not too bad. I think the easiest way is if you follow the steps, have the steps memorized, it's a lot easier. But once again, if you have your own setup for it, that's fine. Just make sure that you indicate the main things, which are your intercepts, your 5 points, 1, 2, 3, 4, 5. Make sure you find your vertex, and list your ABCs, and if the parabola is opening up or down. Those are the main things I look for, along with the fact that you graph the parabola with the lovely arrowheads. Alright, let's use another example. This will be the last one, but let's go ahead and try graph this. Feel free to pause the video and try graph this by yourself and check in with me in a sec. So, what is the first step? Well, the first step is list the ABCs. So, step 1, ABCs. A is -1, B is 4, and C is -9. And my parabola opens, since it's a -1, it opens downwards. And once again, if you recall, this is going to be my y-intercept. Step 2. What do I need to find? My vertex. So my v sub x value is, once again from the formula, -b over 2a. And that is going to equal negative, let's see, what's my b value and what's my a value? B is 4, and a is -1. So this is going to equal -4 over -2, which is 2. How do we find v sub y? Once again, that changes with each parabola because the equation we have is different for each parabola. So we're going to go ahead and use this equation to find my y. So that will be f of, and what are we inputting? We're inputting 2. So f of 2 equals negative, and we have x squared plus 4x minus 9. That looks right. Yep. Oh, I don't know. I put in a -2. That should be a +2. Okay, let's go ahead. So that's going to be -4 plus 8 minus 9. So that'd be 4 minus 9, which is going to be -5. So my y value is -5. And let's go ahead and graph that to -5. I'll graph this one in, what color do you think I'm going to pick? I'm going to go with blue again, my favorite color. Alright, so 2, -5. Vertex 2, -5. Now, let's see, my intercepts. Step 3. X intercepts. So once again, let's real quick check. Do I have any X intercepts? How can I figure this out? Well, my vertex is down here. So I have two options. One, my parabola opens upwards and I get 2 intercepts right here. Or my parabola opens downwards. Which one is it? Oh, it opens downwards. Notice we figured that out in the beginning. So since it opens downwards, are we going to have any x-intercepts? The answer is no. So you could go ahead and try to find the x-intercepts, where you're going to set your parabola equal to 0. Set of 0 equals -x squared plus 4x minus 9. You could try factor this. You'll find out it won't factor. You could plug that into the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. And then you would eventually end up with a negative number inside the radical. You would do all that work only to find out you don't have any x-intercepts, which I myself did on a test once when I was a student. So better to not really waste that time if you can. So what would you do? Well, we already know there's going to be no x-intercepts. So you're going to just write x-intercepts, none. And your reason is going to be parabola has vertex below x-axis and opens down. Okay, so once again, if this happens, I'll be looking for x-intercept none, and then the small explanation below. Doesn't need to be the exact wording like this, but the basic idea, that the vertex is below the axis, and your parabola opens down. And you need to state x-intercept none. Don't write x-intercept 0, because then I'll think you're talking about the point 0, 0. So make sure to state none. Alright, I think I've said that enough. Let's move on to the next one, y-intercept. Do we have any of these? Well, remember, we always have y-intercepts for parabolas. So, for that, let me just go ahead and write down my equation. X-intercepts, how do we find that? Y-intercepts, how do we find that? We set x 0. So that'd be 0, 0, 0. So negative 0 squared plus 4 times 0 minus 9. All of those go to 0. And I'm left with negative 9. So my x-intercept is 0, negative 9. And that looks like it makes sense. Once again, always check your work as you go along and make sure things make sense. If something seems off and things aren't lining up, more than likely some of the math work is off. So 0, negative 9. Alright, we have done step 1, 2, and 3, so now we're on step 4. And what is step 4? It is extra points. And we only do this if we actually need extra points. Once again, we need 5 points total. How many do we have? We only have 2. Darn. Okay, Well, I can use the table of values, x and y, or I could use line of symmetry. Is it possible to use the line of symmetry with my graph right now? The answer is yes. Why? Well, because we have one point that is missing its match. Let me just go ahead and draw in my line of symmetry. Once again, this is not something you need to draw in. But you'll notice the y-intercept is 2 away, which means there must be a point that exists 2 away on the other side. So with the line of symmetry, I have found my other point, which is 4, negative 9. So I have 3 points. I need to find 2 more. Well, I can't use the line of symmetry anymore, which means I need to use the table of values. Well, what point would we pick? We've already had 0 done for x, so let's go ahead and pick 1. I like to pick simple numbers if possible. Well, to find y, we're going to plug it into the formula, so f of 1 is going to equal negative 1 squared plus 4 times 1 minus 9. So that'll be negative 1 plus 4 minus 9, which is going to be 3 minus 9, which is negative 6. So that's going to be the point, 1, negative 6. So 1, negative 6 is right there. We're so close, we have 4 points. We just need 1 more. So I could, once again, do the table of values to find the other point, but I might have an easier way. Do you know what it is? I can use the line of symmetry again. This point exists 1 unit away from the line of symmetry, which means there must be another point that exists exactly 1 away. So let's go ahead and plot that point, and that point would be 1, 2, 3, negative 6. And there are my points. Let's go ahead, graph in my parabola, and we are done. Free as a bird. Always try to make sure your parabola is a nice little curve. Okay, that is it for this section. Once again, if you have any questions, need any help with the MyLab homework or any of the lecture notes, please stop by an office hour or send me an email.